Thank you so much, and I really am honored to kick off the event of a seminar series to talk about teaching, particularly science teaching, as I think I completely agree with you. That's very often we are trained as researchers, and we excel in our field as researchers, and then we're told, okay, since you're a great researcher, just go teach it. But if we didn't teach our teachers to do things, we'd be, oh, you couldn't tell them to go to the school? You haven't trained them to be teachers. Oh, but professors, that's fine. Just go teach them. That's fine. You know what to do. And so it's sort of funny, and I'm not saying that that's necessarily an awful system because it's worked pretty well for many years. The question is if it's the best system. And that's what I want to talk about a bit today. And I would really encourage you to take part in the discussions when I ask you to. Because the idea is you're sitting here with a bunch of people that at least took the time today to talk about teaching. So these are probably good people to talk about without what your concerns are. Based on this talk, I'm also encourage critical questions. These are some findings that I'm going to present. These are things that show the picture can be shifted, but I am by no means saying everything should be tossed out and everything should be do none. New. It should be a combination. So with that, that's the whole point. We should evaluate it like scientists. Look at the data and adjust where necessary. So if you go to most universities today, the typical thing you'll see is a lecture, which I'm actually doing right now. However, there will be no final exam, so it's still a different goal today. What you see, this came from the idea you'd have a monk studying something, and then they hear this rumor that across the Alps is another cloister where they're doing something else, and they'd organize a whole big adventure expedition, cross the snowy Alps, possibly die, get to the cloister, study really hard with this monk to get this information that's very precious, then organize another expedition to return over the Alps and possibly lose one or two people along the way, hopefully not the critical ones, and then you get there and you disperse your knowledge to as many people as you can gather. And 1,000 years later, we basically do the same thing. Maybe we can traverse the Alps a little bit easier now. So again, the question is this the best way to gain knowledge? Particularly if we take into account the way we access the knowledge. So in that case, you had this one monk somewhere who had the knowledge, was the source. And then you wanted to bring that source outwards. Today, the source of a lot of information does not have to be the professor. There's a lot more places where we access it, where we tend to access it. It's more about finding the right information and combining it in the way you need to solve a problem no one else has solved before. That might not be always the best when you're just transmitted the information. So, wrong button. So, on that premises, Carl Wyman, as Zednik mentioned, he was, before doing the Nobel Prize, which I think was for Bose-Einstein condensate, he was also looking into research into physics education because he was noticing the graduate students he was getting were top A's in their classes, but when given lab problems to solve, they didn't know what to do. They knew how to take tests, but they didn't know necessarily how to solve problems. And after about half a year in his lab, they'd be catching up pretty well. And he noticed they were learning more from each other than from him, the professor. And once they had sort of kind of evened that out, that base knowledge from the tests was there, but it wasn't accessible. So he started thinking, what are we doing that we can't create graduates, that we have to first sort of carve our graduate students out of the undergraduate? We want to have undergraduates going through the system that can already solve such problems, because not all of them are landing in graduate school. Some of them are going straight into industry, and we'd like them to have that critical thinking skills and have it there. So once he won the Nobel Prize, he did indeed take his money and say, I'm going to now fully do the physics education research. And he went from the University of Colorado Boulder to the University of British Columbia. And basically, this triangle sort of shows what his main idea was, is everything should be evidence-based. So we should look at what should students learn. So not just what are the keywords, but what are the learning goals. So if they should solve a differential equation in 1D, in 2D, and 3D, should they be able to solve it using polar coordinates? What should they actually be able to do with those things? And then we look, what are the students actually learning? Which our exams may or may not be the best indicator of. And then we should look at what instructional approaches we have that could help sort of bridge that gap. And one of the examples could be looking in, as I say, the learning goals to what students should learn, what they actually learn, and thinking about our tests. Our own exams, very often, we try, of course, to make them the same from year to year, but we're not always perfectly successful. There could be validated tests, what we could say that are conceptual tests that we could given internationally so you could sort of compare. Then you also have to think about what instructional approaches and how you can reflect not only as an instructor, but how you can have the student given chances to reflect on their own knowledge as they're gaining it. Because that sort of, learning is sort of a breathing process. You sort of forget a lot, and then you have to readjust how does it fit in your own mind, and then you're sort of ready for the next bit. So how to sort of give them that space to do that. So there's a lot of research already been done, and a lot of it, particularly in the last now 2 decades, from cognitive science, about how our human brain learns. So we looked a lot into that direction. So it's a physiology as well as just methodology. And then we wanted to measure the effects of what we're doing and share the new results just like we would at a conference or something else. So the 10-year project at UBC is largely winding down. They're moving into the next level of sort of how to sustain the transformation that they have. About 60% of their undergraduate STEM, so science classes, are taught in some form with an activity-based sort of transformation. It doesn't mean it's fully flipped and everything is online. Definitely not. Just means that they're using different ways in the activity for 60% of the course hours that a student would have. Now the next big player is Imperial College London, which I'm associated with they're starting a learning and teaching strategy since 2017, where they're also going to initiate on how to bring that all into the European sort of constraints, the ECTS system, Bologna, sort of more similar to how the rest of Europe also learns. So what is active learning, and how do you actually active teach? Because you could say, well, I active teach, I walk around, I talk, I always am there, I love questions, they just never ask me questions. Yeah, okay, but how could we structure that maybe differently to kind of encourage more questions? So what do I mean when I say active learning? I basically mean anything the students are doing other than taking notes, especially if they're taking notes verbatim. So something can be as little as talking to the instructor. That's an activity. Talking with each other. It can be solving a problem, actively working on it, in class, out of class. Doing experiments. Doing them, not necessarily watching me do them, setting up the experiments, not just doing them what the piece of paper tells me to do. Working on a project, we would all agree that's very active, but also writing and summarizing. And taking the time sometimes in lecture, where it's this full bombardment of information, and we know from the cognitive science, we can only handle about 6 or so chunks of information at a time. Giving them a minute to say, summarize what's floating in your mind right now about what's going on, and maybe formulate a question once you've come up with a summary. Those moments of reflection, to work that in as a norm for the students in the learning process, that's active, although I'm not actively doing anything at that moment, but the students are. So that's really what's key. So I want to just give a little list of a couple learning methods, because as Zednek said, there's not one magic bullet on how to do this. And I'm not anti-lecture, because a lot of people think I am. I'm lecturing right now. Lecture has its purpose, but if you only lecture, and that's the only style you're exposed to, it kind of confines the diversity of thought you're going to get out of that and the diversity of learning. So the idea is to sort of mix and match to things that are more appropriate but you can use the lecture hall still as the lecture hall. So one idea to do is peer instruction, sometimes called think, pair, share. That's what these beautiful color cards are for, because we're going to do a little bit of this later. The idea behind this is you would give a conceptual question, usually multiple choice, but it doesn't have to be, ask the students to vote, then have the students talk to each other and maybe vote again and see if they've changed their answer simply based on their own critical listening and talking skills, because they're going to need that later. I tell my students, if you're right, but you can't convince someone else you're right, it's the same as if you're wrong. You won't get the grant, you won't get the funding, you won't get the job. You need to be able to communicate with the language of your discipline. And this is a safe space to practice that. You're not actually going for the job right now. So I try to get that really clear to them, that that's a skill that very often is never mentioned when you look in all these science things. It's all about, oh, look at this cool experiment, look at this cool theory, oh, this black hole is amazing. And they never say, you're gonna have to write and talk. So these are things I want them to practice. And this is what they can do in this sort of think, pair, share environment. Problem or project-based learning, as the name sort of supposes, is you drive the learning based off of a problem that they'd want to solve. So instead of me maybe giving always the input, I give them the problem and they say to me, oh, but I would need to learn this or this to solve it. Oh, great, then I can give you a mini lecture on this and that. So it becomes, you change the motivation a bit. A problem-based learning is usually a smaller problem, so maybe a homework assignment. Project-based tends to be longer, over a couple class periods, maybe an entire semester. Context-rich cooperative group problem solving means you need different people in the group to solve the problem. So bringing together, people say interdisciplinary teams, so that you have the knowledge coming from within the students from different students. And the context-rich problems means you give too much information, or you require the students to make some sort of estimations or search things out. Students generally, particularly in physics, they see what they're given and say, okay, everything that's given I'll need. But in the real world, that's never the case. So you need to figure out what you need and what you don't need. And so these rich problems kind of give you that opportunity to practice that skill. Just-in-time teaching or pre-class assignments is something I very often use. It's sort of like a preview for lecture. So I'm sure all of you have had that. We're about 10 minutes, maybe even now it's been about 10 minutes. You're already kind of fading because it's really hard to pay attention for much longer than that. By giving my students a pre-class assignment, sort of showing what's going to happen, what's going to be in lecture, they're able to follow lecture better. And they're very often able to ask better questions because it's their second exposure to the material, not their first. I'm not preaching, I film myself an hour lecture and they should watch that because that would be really boring. I'm saying small targeted things that are maybe the basis of definitions that they could then use when they come to lecture already. So that's something they can do in their own time, and they can also schedule that when they want. Then I very often use these PhET interactive simulations. These were also developed by the University of Colorado Boulder. They're for all the STEM disciplines. They range in difficulty from middle school level to undergraduate level. American undergraduate level, fair enough, is probably maybe first, second semester in the European system, but still they're sort of gamified and they are rigorously tested for research also on the student side of what they could learn out of it, as well as university lecturers who use these, and maybe in conjunction with like a worksheet, they'll often upload their materials to that PhET. So you can take what they have already done and use it as is or adjust it as fit. So it's a really good materials source for people. And I will use that sometimes as a pre-class assignment, that they kind of play with, for instance, the wave on a string, and then the lecture is going to be about the wave on the string. And the last thing I just want to mention quickly is the two-stage exams and reviews, or just the idea of what are different kinds of exam and review structure we could put out there, because for better or worse, testing drives learning. So we should look at our exams to see if that's really getting the learning that we want out of it. So transforming the lecture, what does it even look like? So you can do it in a regular lecture hall. You don't actually have to physically change your space. You just maybe have to change the sort of cultural norms of what happens in that space. So the pilot study that we did at UBC, which was back in I think 2010 already, we had 500 students taking introductory physics. They were engineer students. And we had one section taught by the regular professor, what we all know, sort of a regular lecturer at the front, doing his best, of course. Then we had a second person who was trained in these different didactic methods, who used pre-class assignments and peer instruction largely to drive the class forward and include large sections of discussion between the students based on conceptual questions. They were supposed to cover the same amount of material in the same amount of time, namely electromagnetic waves, in 1 week. Or at least a part of it. And then they had a common exam, which was a pop quiz, so the students didn't know it was coming, on the Monday after the week was done, to sort of see what have they recalled or what have they retained from these teaching styles. And what you see here, if you look on the y-axis, is the number of students, and here's their score on this conceptual test that was agreed upon. The control is in the light gray. You see a nice distribution, around about 5 of these were conceptual questions mainly, so about 5, and you see a much broader and higher distribution for those that had the experimental situation. What's impressive is really all of the students sort of shifted upwards. You don't have sort of a flattening, or you don't have sort of an odd shape. You really see that the students engaged with the material in a different way. This is a conceptual questionnaire. If my final exam doesn't require any conceptual understanding and just some mathematics that are reproducing the homeworks that they got really used to doing, I might not see improvement. So again, that goes back to what do you want and what are you asking the students to show you? So this is a more recent study from 2014. Freeman et al. Did sort of a meta study on all the publications that are out there. Like I said, Carl Wyman is not the only person doing this. It's been done for many years before him as well. And they looked into 225 different studies that looked at analyzing some form of active learning with traditional lectures. And basically what it comes out is you do see that there is an increase in examination performance by about half a letter grade, which is not non-significant. And if you're in a traditional class, you're 1.5 times more likely to fail in that class. Again, you could ask, there's a lot of things in there, there's a lot of gray zone, but when you look through the literature and what everyone's reporting, you see this shift, and it's really somewhat undeniable, to the point where Carl Wyman, who likes to be a bit provocative, always says, maybe we need to defend why we're even using lectures. So he says, if you were testing a new vaccine, you would compare it to the next best vaccine. When we compare active learning to traditional lecture, it's like comparing vaccines to bloodletting. At some point, you have to just say, it's better than that. Now let's try and get this to be optimal. So the things that we're now doing in the research field for particularly physics education research is looking at what can we do within the active learning to make that more effective, as opposed to always comparing it back to the traditional. We feel at some point we say, we've sort of shown that that is not the most effective way. And again, I'm not saying flipping everything, I'm just saying vary it a bit. And again, the students are starting to recognize the benefits, so this is beginning to happen now more and more. Once some courses were transformed, the students were, the norm for them was the transformed class. It was the interaction with the professors, it was the interaction with their colleagues, that when they entered a lecture hall, say as a junior, so 3rd year, and they were presented with just a frontal lecture, they were like, excuse me, I'm not learning from this, I want to talk about it more. So the students are also very, very quick to check if they're learning or not. It's comfortable to sit back and listen, obviously, but it's not, it's sort of more work to actually do something. It's just like going to the gym a little bit. It's more work to actually go and do to the gym, and you need to sort of motivate yourself to go, but once you go, you're like, I'm so glad I went. It's sort of similar to that with the learning. So I want to give an example here with peer instruction, because I think this incorporates all of this, and it's a very easy gateway. Drug is probably the wrong term to use. It's a very easy gateway method to start doing active learning without massively changing your lecture. So when I say peer instruction, I sort of mean this. You have the instructor at the front poses a question, usually multiple choice, but again, doesn't have to be. We'll do an example where it's not necessarily. And then you give time for the students to individually think about the answer. It's important to give those students time because although I say it's important to talk to each other, it's also important that everyone has space to think for themselves what they're going to say. You have people like me who are very quick to be like, and you have other people who need a minute. So this way you want to involve everybody. So this is the time where everyone should be quiet and think for themselves. Then you ask them to vote. And you can have them vote with the colored cards, which is what we're going to do today, because first of all, I'm very low tech, and second of all, there's always a problem with the Wi-Fi somewhere, so this way I avoid all that. But there are many, many apps. There are many, you can actually have little controllers that just do this function. You can have those bought by your university. It doesn't really matter. The key is vote. Because once you vote, you're more intrinsically involved. So you can sit back and see the question, and I'm sure if you watch this on TV with Who Wants to Be a Millionaire or whatever, you're like, it's A or B, and they say that's B, and you're like, yeah, I knew it was B. No, you didn't. You didn't vote. You need to commit. And once you commit, you're gonna notice the answer in a different way. And then you sort of have a bit of ownership within that question, and that changes the motivation. And then this is actually where the peer part comes in. Up until now, it's really not peer, even though it's called peer instruction. This is the part where I would say, discuss with your neighbors. Ideally, I have a really good question where the distribution is a third, a third, a third, or a quarter, a quarter, a quarter, or ideally a fifth, a fifth, a fifth, a fifth, a fifth. That would be great. Not all my questions are great, though, but still. You see this distribution, and at that point, the students also recognize they're not alone in their thinking. There's all people thinking different things, and they're ripe for conversation. And very often, instructors are scared. They're going to say the wrong thing, and they're going to convince each other the wrong answer. I have to interject. no, because we basically know they're not listening to you a lot of the times anyway, so just let them do this, because this is what they're going to have to do later anyway. So this is the time to practice that. You can still get the answers as the instructor and fix things that broke, but what we're seeing is largely that that's not the case. So that fear is somewhat not founded. So this is the discussion with the neighbors without me being the source of the knowledge. I'm starting to get them trained and them being the source of the knowledge and critically listening to each other when they discuss things. Don't let yourself just be convinced because this person you think is smarter. Listen to what they're saying and be able to argue sort of back. So this is really this practice of being a scientist, essentially. So this requires more effort from the students. So like I said, I have to sort of change my way of doing things in the lecture hall. One of the things I actually did, if I know that my classes allows for this, is I will block off the 4th row. Every 4 rows I block off. I didn't do that today. That allows me a space where I can actually walk to the inside and sort of penetrate the middle of the lecture hall. Usually, even if you have a very full class, the first day of classes, after week 2, there's enough space that you can block off a row or 2 and you'll be fine. And then the students are used to it because a lot of students won't raise their hand in front of 200 people to ask a question, which is completely understandable. But if I'm walking by, they might be like, oh, actually, wait, I just had a question real quick. So you can really get into discussions more that way. I also need to have the students sort of understand that I want their real answers, and being wrong in this space is absolutely fine. It's a learning opportunity. Own that you're wrong. Because if you come up with an excuse why you were wrong, you won't actually listen to what was the correct answer because you'll be so convinced it was just a misunderstanding. So say, okay, I was wrong, I voted B, I want to know about why I can fix this. So you sort of change a little bit the dynamics of the class, but that's usually after 1 or 2 classes, the students get very used to it, and they usually, as I say, they start requesting it once they get really sort of used to that format. That being said, I want to show one of the PIs in action. This is from a geology class, so you don't have to answer that question correctly, don't worry. The idea is, what did the students vote? So here you see the solo vote, and again, you see a really good distribution of votes. The students hardly have to be primed at this point. They want to talk. They see that there's a lot. I mean, usually you're sitting there and the person next to you is writing a lot, and this person's writing a lot, and you're like, I'm the only person who doesn't understand what's going on. But now you know I'm not the only person who didn't understand what was going on. There's a lot of people not sure about this question. And the professor in this case did not give any hints. They just said, great, it looks like there's a lot of different opinions here, let's talk about it. And this is what happened. Spoiler, C is correct. The majority originally did not have C. So you don't have to intervene and be like, oh my God, they're gonna go off the wrong path. You just have to let them talk and maybe remind them, listen to good arguments. And you started to shift actually just from having someone say, I thought D because of this reason, and someone says, no, but now that's not right. I thought A because of this reason, and the other person says, no, that's not right. And they both go, oh my gosh, is it C? So you can really have that. And we've seen this actually with multiple choice exams where you can actually do a regression study as to what pairs people had and what happens after they talk to each other. The third one, this point was for research. They wanted to give a hint and see what happens after the hint. Generally, this third graph is not necessary. I would usually jump in at this point as the instructor to someone to sort of now continue forward and maybe add to this question a follow-up question at this point. But this allows me to see that there's a large distribution of what students think, so I know what level my students are at, and again allows the students to see that there's a distribution within the class. Because a lot of times you don't know that, and you feel isolated, and this makes you feel more as part of the learning team. So this is the question I use in my own lab, where I have, I actually usually have a demonstration at the front. I think a lot, is there some physicists in here? Can I get a Newton? No? No physicists? All right. So this is one of the ones I use in my introductory physics class, and generally physics, we always like to have demonstrations at the front. That's like a big thing. You have your demonstration at the front, and you're all excited about it, and the people are kind of can't really be bothered, or they just watch to be polite. So this was my demonstration. It was about buoyancy, and it's somewhat boring. It's a scale, and it's a ball. Yeah, okay, I can see where maybe you're not so excited about what's coming out of it. But by having the students predict what would happen, this was the results I got. There is a very large spread. And a non-significant amount of students, 12 people, actually thought if I add a 1.5 kilogram to a 5 kilogram beaker filled with water, I will make mass. it's pretty cool. Like, I don't need the sun. I could just make mass by putting a thing in the water. This is great. So I never would have thought people would have chosen that. And I don't mean that to sound condescending, that these people are silly. They're trying. That's what I want. But they probably would never raise their hand and ask that question either. So this gives them space to sort of vote what they see. And now we have this big spread. And at this point, they want to see what happens. They're actually curious what's going to happen when I do the little ball on the scale. Which before, they'd just say, oh, okay, so it rose to less than 6.5. All right. So this engages them in a different way. Now this, you could say, is not really peer instruction, but I could have them talk about this because there's such a spread. In this case, instead, I decided to show the demonstrations. So when I say peer instruction, it's a little loosely defined. It's not always this exact regimen. It's based a bit off of how is the mood of the class, what's the best way to solve the question at hand. That being said, I wanted to do this with you guys. So everyone has your cards. So A, B, C, D, E. E is just going to be like your hand, because normally I have a white one, but we don't have a white one printed. So these are your cards. This is the way it's going to work. I'm going to present the problem. This is the real problem that I always present on day one of my teaching to exactly set the norms for the classroom. So I'm going to have you guys fill it out just like students. Please take it seriously. And I'm going to start now. So we're welcome to Physics 101. I'm so excited to have you here. We're going to do a lot of lab demonstrations. I'd like you to make a prediction on our very first one, please. So, do you feel you could vote? So this question? Ah! Oh, that must have happened when I transferred it. Sorry, yes, it is A, B, C, D. Thank you. Very astute. Are you ready to show your answers? Don't worry, it's okay. This is part of the whole process. It's okay to not be sure. That's what we want in this classroom. Again, we're in the classroom. I want you to learn, own what you think. So please take out which card you believe to be correct, and you can hold it in front of your chest so you don't have to completely show if you don't want to. And I'm going to tell you roughly what I see. Thank you very much. I see some people abstaining. Please don't. This is for your own learning. And I see a really colorful mix, actually. I would say 40% C, 20% D, that's 60, and then probably about 25% B and a scatterings of A. Wonderful. Please talk to your neighbor. If they said the same thing as you did, say why you said it. Thank you. So, thank you very much. I hear a lot of active discussions. This is really fun for me because usually the discussions are in English, so I can like listen in a bit what you guys are saying. And this time I was like, I have no idea you guys could be talking about your weekends, but I'm hoping you're talking about this question. So, after having discussed it with your neighbor, this is always the hard part, is getting the attention back, but that's okay. After having discussed it with your neighbor, please think about it for a minute if you agree with what they said, if they agree with what you said, and I'd like you to now re-vote for the same question, please. Take a second. So I see an overwhelming shift to D with a handful of C still remaining, which was the majority before, and a scattering of A and B. So instead of having you discuss it once more, we're actually going to do it. I've already warned them that there's going to be a mess, so hopefully they'll invite me back at some point. We'll see. So I need 2 volunteers. Peter, since you're an organizer, you're going to watch very carefully. Don't go stand too close, you'll get splashed. You're going to watch very carefully, and you're going to help report to the people in the back what's actually happening. I need a second volunteer. No, you're already the organizer. Someone else. Thank you, great. You're going to need to listen, because very often acoustically you can hear what's happening, okay? So everyone, yes, exactly. Whoops, wait, that doesn't count. Hold on. All right, so to prove that this has a hole, there we go, and it really shoots out. All right, you ready? Could you see? Well, what happened? It didn't flow. Could you hear sort of a difference in the not so much this time? Yeah, because it didn't. Normally I'm a bit higher. Great, thank you so much. So you agree that it didn't flow. You saw that it didn't flow. And I'm sure you actually are curious now why. If you weren't sure, hopefully you discussed it since many of you shifted to D. Thank you. The idea is that when you have the cup and you have the hole, you have sort of the column of water and the air pressure pushing down and sort of a gravity column almost pushing that water out of the hole. When the entire cup is falling under gravity, you lose that sort of air pressure column on top, so there's no reason for it to be pushed out the hole. So what I saw, though, was at the beginning, so going back in sort of the didactic mode, at the beginning, there was more people who voted C, well, C, that it would keep coming and flowing horizontally while the cup is falling. And without me saying anything, now granted, we are in a room full of academics, I do recognize that, but still, you were able to shift over to a different thing. And I do believe you were more curious to see that experiment had I not asked you to do it ahead of time, and more aware of what is the thing you're looking for to get out of that experiment. Because a lot of times, for instance, with electricity, you might have something in parallel or in series, and you say, is the light bulb dimmer or brighter? And it's hard to even tell, but when you sort of have been trained to look for a certain observation, you're much more keyed into it, as also the takeaway message. So this is something that I do with my class to sort of show this is going to be the norms, and this is how we're going to do things here. You can, if you want to look as well, there's a demo, go to YouTube, that's where you do everything, and you will find a video showing this as well. So a follow-up question I have for you is going to be more on a didactic level. So having experienced that right now, and so before you look at this question, I see you're all looking there, but look here for a second. A lot of instructors do demonstrations at the front, and not often do they have you predict the answer as I just had you do. So assuming that students, we want to do a comparison, this question is asking comparison, students who would passively just watch a demonstration with an explanation, I wouldn't just do it, I would explain it, or if they would predict forced. So that's, or no, sorry, or if they've not seen the demonstration at all. Now, what you might notice is in this case, my answer choices there's basically no numbers. What I'd like from you guys now is for you to think, what do you think the right answer is? So-and-so percent worse, so-and-so percent better, or no change. Come up with that number, percent, with your neighbor right now. And we're going to collect those numbers so that you're going to create the answer keys that which we're going to vote on. Okay? Is that understood, sort of the idea? Take 2 minutes, please, to talk to your neighbor and come up with a number that you guys would suggest to me should be the correct answer. And we're going to slowly fill in our multiple choice. All right? Okay, thank you very much for having that discussion with your neighbor. I'm going to ask for a couple of volunteers so we can fill in sort of the choices. So if somebody could shout out what they and their partner were thinking, a number, then I'll put it in. So when I also say understanding, I was asked this question, what does it mean to understand? So I purposely left it vague, I admit this. The idea is the lab results that I'll show you, or the research findings I'll show you, was looking into a later exam where the students were asked to predict an outcome for an experiment and explain the underlying concept. So that's why I sort of put that as into understand. But it is vague. That being said, so it's sort of how much better on that exam. What numbers did anyone come up with? You can just shout them out.
20 plus.
20 plus? Yeah. Okay. So we got 20% better. Anyone else? We got another number? Oh, wait, that made check things happen. No! How do I make no? Shift, thank you. Got it. Another number, please? Doesn't have to be at this point, no. Sorry, I heard something?
Yeah, 30% worse.
30% worse. All right, I like shift. I learned the shift button. Another number? 15 better. All right, so it's a little out of order, but I trust you to handle that. And do we have anyone else for worse, or we're done with worse? That's fine, we can have 4. Then we'll just shift everything down by 1. All right, I know I'm asking a lot here, but I think we can do this. So, given these numbers that you guys have come up with, I'd like to see a vote on what you think. So 30% worse, no better, 20% better, 15% better. 15 and 20 is, of course, close, but let's just see what we see.
30% worse.
Yeah, yeah.
Oh, so 30% is A, okay. So no better is B.
Yeah, we're just shifting a little bit. I did say it's tricky. This is advanced. So I see, again, very colorful, actually. I'd almost say a quarter, 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 quarter. So everyone is really, we have everything. Some people think, yeah, you'll definitely get worse. Some people think it better, and some people think in between. So, but since 2 of those options were better, and it was a quarter, 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 then really I'd say half think it's better. We'll make that assumption. So back to presentation mode. There we go. So what is it actually? What they did at Harvard was they were also thinking the same thing. Are these sort of entertainment or are they actually learning something? So they set it up such that the students rotated what they saw. It wasn't just one group of students were always given demonstrations and one group was not. That would not have been fair or ethical. Instead, they have a semester long, and there were some classes where they'd get the demonstration well done, like prepared and spoken about the way you would want to do a demonstration, but no prediction. Some would have no demonstration whatsoever, and others would have to make a prediction the way we just did with a multiple choice answer. And then others were given a full sort of thorough discussion where they had to make a prediction that they had to write themselves. They were not given multiple choices ahead of time. Then they had to vote on the ones that they've done, sort of what we just did where we gathered the information from you. Then they would have a worksheet where they'd have to record what they saw and they'd have to reflect about it. So very thorough demonstration. And that, of course, tells you how much time those things would take. No demonstration, 0 minutes, as much as 20 minutes out of the lecture, which is a fair chunk of lecture time for a demonstration. What they saw is they measured at the end of the semester, they had a final exam where they had two questions based on a lab demonstration where the students had to predict the outcome and describe the underlying concepts, explain what was happening in it. And what you see here is the people who did not see it had about a 61% correctness on what would be the outcome of the experiment. The people who just observed had a 70%, but if you look at the P factor, that is statistically insignificant. Meaning they basically were the same. So that 11 minutes, not really bringing anything. However, by 13 minutes, so 2 minutes more, you actually see a statistically significant increase in how they can predict the outcome of the experiment because they're engaged differently. By having them do the full discussion, you do see also an increase, but I would argue when you look at the explanation, so this is how good they could explain what was happening, the numbers are a bit on the low side generally. However, despite that, you again see the p-value here is completely insignificant. You do see a significant increase, but this 2%, I would argue, is not worth the extra 10 minutes of class time, because class time is also very valuable. So my one thing here is to say, if you're going to do demonstrations at the front, take the 2 minutes to do the prediction, or don't really do it at all. So this is one thing that I wanted to sort of show you of what the research can show us to kind of help us determine what we want to do. So again, I'm not comparing this always to a traditional lecture. I'm looking at one facet of a lecture and how could I improve that through active learning. I could still do my full lecture as such, but only involve that one vote, and I'd already have a more active teaching. So that's sort of what I'd like, and I think is also the idea behind this seminar series, is to start talking about those kind of changes that are low sort of barrier to change without going like, I have to change everything and I don't have time, because of course you don't, you're researchers and you're students and you are limited in time. But there are small budgets you can make that can make large differences. So I have one last question for you guys to vote on. I have to say I lost track of time.
Just to be on the safe side, are these experiments reproduced?
So this one in particular. So this was done with, I want to say the numbers were somewhere between 150 and 200 students, so you do have some statistics security. I don't know of this exact one being reproduced, but we are trying to reproduce the results more and more often. But as in any research, they don't tend to get published when you reproduce something. So it's really hard to say how reproducible the thing is. There's a lot of other evidence about that shows from the cognitive point of view how we engage, that shows from the social dynamics, that I feel there's enough evidence that this sort of lines up where, again, in this particular case, where I'm arguing for, or I'm suggesting.
Just questioning, we know the recent problems of psychology, that a lot of basic experiments actually are never reproduced.
Yeah. No, it's also very hard to do these kind of things. You have to have a pretty, it's not neat and simple because you are a live giving class. That's why I said you had to rotate which students got which for ethical reasons. So it is very hard to sort of cleanly always reproduce and do the exact same thing and publish would probably not so many people do it. You're right. What I try to say is look at as many of these as possible and see the small shifts and which one fits you. So like if you're not giving lecture demonstrations, I wouldn't suggest you to now start. But if you are giving lecture demonstrations on a regular basis, this might be something that particularly speaks to you. So that's also the thing, is really no silver bullet. It's the idea of what matches with what you're teaching. If you're in a lab, this will probably be more interesting to you than if you're a theoretical biophysicist, which is fine. Then, you know, so that's, but I agree with you. It's hard to say how reproducible everything is, but we're seeing sort of the evidence accumulating. Right, so this is the last question I wanted to have. This is a two-part question for you guys. So learning from lecturing, how much do students on average learn in traditional physics classes? And again, as measured by performance on a conceptual survey. I mean at the end of the semester. For America, for America. So that drops it like, yeah, okay, fair. For America.
Is this before test or after test?
This is, they've taken the test at the beginning of the semester and they take it again at the end of the semester, and you look for the change over the semester, essentially. So that's the idea of how much more have they learned.
Were they preparing for the test? I mean, did they know?
Did they know that the conceptual questionnaire was coming again? I couldn't say. I think this was taken, let's say, 1 or 2 weeks before the final exam, so it's sort of in that realm of time. Yeah. Mm.
So this is on the university level for physics majors?
For physics majors, this is a combination of lots of different, the results are going to be a combination from lots of different ones, so it's for introductory physics. It can be physics majors, it doesn't have to be physics majors, but it is a mix, but it is physics class.
You want to learn more about these tests? Look up the keywords
Yeah, that's what I'm going to show that in a second. I'm going to show that in a second, yeah. There's one more question in the back. Sorry, what? You vote for E with your hand like this because I forgot to print an E. Oh, and I forgot to repeat the question, sorry. But yes, the questions hopefully did get heard. So I'd ask you to vote what you think now for this one. So I see some E's, but I actually see largely C and D. So I'd say about 40% C, 40% D, and a handful of E's. So D and E, okay. So now I'm going to ask the same question, but we're going to change it to a very interesting, clear, and engaging teacher, such as myself giving the lecture. What do you now think? So, some of the people who chose E stuck with E, but I see a shift to more B's and D's. So, I want you to talk to your neighbor just for 1 minute quickly on what did you think between those two questions. Some of the conversations are dying down, so that I'll take that as a cue to keep going. So, I hope you enjoyed discussing this with your neighbors and sort of seeing that the shift was happening. So there was some people who said, nope, it's still the same number regardless. And there was a few people who said, well, once it's an interesting, engaging person, then of course it's a little bit better. Which we'd all like to hope. And it's not true. Oh, kick to the gut. Oh, it doesn't matter how cool or fun you are. So it's basically, this is a graph here that I'll pick apart in a minute, but basically it's the human physiology of our brain and how much we can absorb is pretty much a set level from this traditional transmission mode. So what we see is, this is an older graph from 1998. This was the first one of its kind done in the early-ish days of physics education research at the university level, so not targeting future teachers. And what they did was they gave this pre-test here, and conceptual 30 questions called the Force Conceptual Inventory. It's conceptual mechanics, and the idea is this, they have this pre-test coming in because mechanics is very often, you have sort of gut instinct from your everyday life that is not how the physics and the math describes it correctly. So they come in with these misconceptions. So you basically want to capture a picture of what was their pre coming in, then you've taught them mechanics for a semester, and what's their post coming out, versus, and the gain value is their post minus their pre over sort of the potential they could have gotten. So if you have a better student, of course, you'll have sort of a smaller fraction there. But what you see is this is known within the physics education research as the Hake plot, because this is known so recently that this 23% gain on this FCI, which has become translated in many languages, it might be translated into Czech in the meantime, I'm not sure, but it's definitely translated into several languages. This 23% is fairly rigid. When you have IE stands for interactive engagement, which is essentially active. When you have more active things, you see this distribution spreads by about 2 standard deviations away from the mean. And the idea is not that there are some students also learning the same amount, but the potential to learn is different and it's higher, and it's showing that conceptually they've confronted the material on a different level. But again, I'm asking specifically concepts, but I would hope, so when you read a lot of these questions, they're questions that a lot of physicists would say, of course, someone who graduated or has passed first semester physics should know this, and then you show them that, and the students didn't know it, even though they maybe got an A on their exam. And that's exactly happened to Eric Mazur at Harvard, which is one of the reasons that he started doing peer instruction, and he has a book about his sort of adventure doing peer instruction, because he also was convinced he was an engaging lecturer, got wonderful student evaluations. Students did well in his exam. He gave them this 30-question questionnaire, which was made by someone in Arizona State. And him being from Harvard, he was like, Arizona State, clearly my Harvard students will do fabulous. And they didn't. And that made him really sit up. So a more recent data is another meta-study from 2016, where because this FCI has been around for so long, it's been done so often that now we can really say there's been over 50,000 students have taken part in this survey, and it's been reported in literature. So I'm sure even more have taken it that hasn't been reported in literature, because they're not always shown what they do. And you see this about 23% gain is really a very clear number that you get from the traditional lecture, and you just have a higher potential when you look at what's happening in the interactive education circles. This is also, I mean, clearly this is different papers, so you could argue it's instructor independent, but there was a group in California that really wanted to also try and do an experiment to sort of see, is it really instructor independent? So what they did was they had all these different semesters, first year introductory, mechanics, physics, taught by very different instructors, ranging from instructors that had been there for many years, very well-versed instructors, to brand new instructors, female, men. Here is plotted on this is, again, the learning gain that they could have had from the force concept inventory. Here's this Hake average. They had at Cal Poly already had a traditional average because they'd been taking the FCI already before the transformation. So they had a traditional average from their students at about 29% gain. And then they saw this from all their different instructors. So, of course, there's variation because the instructors are all different and the cohorts maybe change a bit as well. But what you see is that the potential is much higher for those students coming out of that to have more conceptual understanding and be able to answer these sort of basic conceptual questions about mechanics. So I'd like to just present one more research finding, particularly on peer instruction, since that's a little bit what we did today. And this is from a group, Michelle Smith, who's now at Cornell. And this was, I think, when she was in Maine. She started, the question was, is the peer part really necessary? Isn't the voting enough? And can't we just explain the right answer? Because again, the fear is often, that way I know I explained the right answer. They don't get confused by maybe hearing the wrong answer from somebody. So they wanted to look into that a little bit. And what they wanted to do, so I'm going to walk you through this graph because it's a little bit much. So we have sort of 3 cases. One is the peer discussion case where the answer is an individual, just like we did. Then they talk to their peers and answer the same question after talking to peers. That's exactly what we did. Then they're given the answer from the front without an explanation. Sort of like, okay, and as we see, the correct answer to that question would be D. Something like that. So they do know what the correct answer is, but they're not given excess information from the instructor per se. Then this case, the instructor they answer the question as an individual, the instructor can see what they voted, but doesn't have them talk to each other, but instead explains to them the correct answer. So they voted, and they've been engaged at least through the vote. And in the third case, in the third case, you have this combination. So you have, they vote individually, peer discussion, vote again for the same question, and now the instructor explains the answer. So maybe adds more to it, gives it some context around it, maybe gives an example. And at the end of all three of these, there's a second question. And this second question is isomorphic to the first, meaning it's asking sort of the same thing, but in different words, different numbers, but it's sort of the same concept. So if there's any learning that happens between Q1 and in this discussion time, you should see it and that they should answer Q2 more likely correct if they've sort of learned the correct answer from Q1. And this is only answered as an individual, so there's not an influence from peers. Sort of clear, hopefully? So what you see is this sort of mean change of if you got question 1 wrong and then you got question 2 right. So sort of was there learning between the two questions. And this is the mean from each individual student. Each individual student is looked at and then the mean of that sort of aggregate. Gets kind of statisticky, but let's just go with that. And what we see though is when you say, okay, basically these students, it's sort of the gain that they're learning from question 1 to question 2. And in the peer discussion mode, just from their peers, they are learning, which we saw here a little bit in our own example. From the instructor explaining, they're also learning. So that's where you can say, okay, then we don't need to do the extra set. But when you look at the combination mode, it's very clear that they learn a lot more, or a lot more of those students are able to answer that second question correctly. And the idea is that you're getting two different perspectives in this case. You're getting the perspective from your peer, and you're getting that sort of expert input from the instructor when you're ready to hear it. So you're kind of getting like a two-level explanation. And that's allowing you to understand the depth of the question better and able to transfer it to a new question. But then people say, yeah, but maybe that only benefits the students who are struggling, and the really good students are bored because they get it right all the time. Very valid question. So what they did is they broke it down into weak, medium, and strong based off of, I think, pre-scores coming into the university and midterm scores. Midterms in America are like mid-semester exams that are very common. And what they look at is what was the combination here. And if you look here at the strong students, what's sort of interesting is that the peer discussion, they do quite well. They do better with the combination, and with the instructor only, they actually don't have much of a gain. The hypothesis behind why that is that these students maybe were getting them right, or when they got it wrong, it was like, ah, yeah, of course, and they weren't really listening to what the instructor was saying so much. And when they were doing the peer discussion, again, this is hypothetical, but they think they were in the position of explaining more often because they were the stronger student. And we know when you teach, you learn, because now you have to really know what you're saying, or they might ask a question that you never thought of and then you think differently about it. So it kind of made them be little professors for a small moment, which made them learn in that moment because they were teaching. And that's in the combination, that same thing. So you could almost argue they taught their peer and they were ready to then listen to the instructor to see if that matches what they just said to their peer. For the weaker students, you don't see a large difference between peer discussion and instructor explanation because they hypothesize, in that case, for the weaker student, both sources are equal as experts. So if my peer told me something that made sense, I accept it. If the instructor says it, I accept it. But you do see for the weak in the middle still the combination, just that hearing of multiple sort of ideas twice kind of lodges in better. So again, this is sort of the idea that if you're going to do the peer instruction, you may want to take that time to include the extra part where the peers do talk, because the instructor only has limitations. That doesn't mean for every single question you have to say, okay, now we vote, then we have a second vote, then we have them talk. You do have to be a little bit open. If I have a question, which happens, and I think it's a really good question, and 80% get it right on the first vote, there's not much learning potential, actually, and I'll say, wow, okay, great, and I will move forward because time is still precious. But when I see a good distribution, that's a good opportunity to learn, and I'm going to take the time to allow them to have that moment to learn and to reflect. That's the active part. So, again, lecture is not the enemy. The lecture hall itself is also not the enemy. Of course, there's amazing new lecture halls being designed with sort of mini islands where you can penetrate easier, where it makes group work very nice. That's wonderful. But that's also restrictive. You don't have to have that. I don't know if you even noticed when I was walking around when you guys were talking, it changes the atmosphere when the person is walking past you. I had several people ask me a small little clarifying question, which I doubt they would raise their hand to interrupt with such a small question. But walking by, I think they found it nice that I could immediately respond. So again, that just sort of breaks that barrier between the us and the them, and it becomes a sort of a we at that point. So all of the things I gave examples of, peer instruction and all the ones way back at the beginning of the talk where I said there were all these different methods, they all embody the components of effective teaching, essentially. And that is that you connect with their prior knowledge. In the example with peer instruction, I had you sort of think, what do you think first? So you're almost ready to put the new knowledge in. The motivation can be changed or can be used. Hopefully I have questions that are either useful or interesting. So if you were my student, that may be useful for your degree program. The ownership, by voting, you're now more involved in this question. And then the achievability of, can I answer this question? Is this something that would be within my realm? That is maybe more for projects, that you want to have an achievability that they could achieve a project as opposed to maybe a single question. Then, again, we want to apply what is known about memory, so not overloading, giving little pauses for people to reflect and to sort of have those moments to discuss. Essentially, we're having them practice being scientists, which includes this sort of metacognition, saying, does that make sense? Wait, what about if this happens? And in a lecture mode, you're kind of catching up the whole time. It's very hard to step back and be like, does that make sense? And when you do that, it tends to be at home with your homework when you have no expert around to ask. And then you go to Google. So it's maybe better to take that opportunity to do it here where you're with your peers and you have people to really ask straight up. And that's, again, with the Google, taking into account digital spaces on how we can give specific feedback. So in this case with the cards, I could see immediately what you thought, and I could change my lecture accordingly. Like I said, if everyone got it right, then I might go a bit faster. If everyone's really in depth in their conversations and I'm hearing really good discussion, I might let them talk for 2 more minutes than I normally would because it's so great. So you get that feedback as an instructor that generally you don't. I think we all know when we say, any questions? And no one asks, and you're like, does that mean you understood everything? Probably not, but no one's asking any questions. In this case, when I walk around, I hear a bit more what's going on, and I see it with the votes. So I get feedback. But the students also get feedback if they're the only ones who voted that, if how many other people voted it. I know one student she had this really nice quote. She said, she always really liked it because if she got it right and other people got it wrong, she was really proud. And when she got it wrong and everyone else got it right, it was a real kick in the butt that she has to do her homework better. And I was like, that's exactly it. It gives you these like little feedbacks every once in a while without having the stress of an exam all the time. And use the digital space. So I use it for pre-class assignments. You can use it for FETs. You can sort of have the students have interactive chat rooms. I'm sure some of these things exist. Don't do all of that. But find one that you feel works really well with your course and with your teaching style. So with that, the takeaway I hope that you leave this seminar and come back to the next seminar with is the idea that active students can learn more. This interaction and feedback is really the critical part. It's good for both the instructors and the students. You can reconsider how you structure your lecture. It doesn't mean you throw everything out. It just means you think about where are the opportunities where you could maybe build in some active learning. Think about what are your learning goals. Are you testing those learning goals? What methods would maybe be more conducive to those? And are you taking advantage of the digital space that you have at the university? A lot of students appreciate having that sort of freedom of doing things at home as well. Scholarship into teaching and learning, that's the research results I showed you. You could also consider getting data from your students. I'm not sure what the ethics are for all of that, but in any case, that's sort of the idea of some of the research findings I was showing you. And I concentrated today on content, on understanding concepts better in the STEM disciplines. But that's not the whole picture. There's a lot of evidence that's much broader, that sort of speaks a little bit to your question, not reproducibility, but what other measures do I have if this is effective? And what we're seeing more and more is that the attitudes are improving of both the faculty and the students. You have faculty that originally said the students are just stupider than they were 20 years ago. And after engaging with the students, they're going, oh, actually, they haven't had access to this in high school, or this, and oh no, maybe there's other reasons why is not happening. So it changes their attitudes, and it changes a lot of times the students' attitudes where they feel they're listened to more, they're getting critical feedback. It's not an us and them, it's a we. The professor genuinely wants me to do well in the exam. They're not trying to trick me. It sort of breaks that stereotype. And we also see this increase of sense of belonging. And when it's, again, sort of one of these things that's a chain. So if you feel you belong to the faculty, then you're more likely to engage in the faculty in a positive way, and then you're more likely to maybe find a mentor, and then you're more likely to, and it keeps going. So it's hard to measure those things. We have some questionnaires for sense of belonging, we have some questionnaires for motivation, and you can piece those together, but they're a vaguer beast, but they're there, and the indications are more and more clear that these things are happening, as well as diversity of thought, because you have different people talking to different people more often. So with that, talking as the main point, first of all, I want to say thank you, because you guys, I think, really participated, which was great. But we're not done yet. So I would like to invite you for the last 10, 15 minutes, because these are people who came today who are actually curious about teaching and learning. And in the spirit of the seminar series, I think the idea is not so much, oh, we invite someone and they show us their fabulous research. I actually showed you a lot of research that I was not involved in. It's more to stimulate ideas of what you could do that's feasible in your class, in your time frame, with your constraints. What do you like? What did you say, yeah, that I'd like to do, the other one not so much? That's fine. Let's take the time, instead of walking home now and thinking about it and then forgetting about it tomorrow when the next deadline comes in, let's take the time now to talk about a couple of these questions. And so in the future, you can come up with your own questions and themes, and that's why we're going to have an online thing where you please propose more topics that you'd like to hear and sort of exchange ideas about. But for today, I sort of broke it into quadrants. So the back quadrant, and you can decide if you belong to it or not. You guys can talk about what are your learning goals for your students, and how would active learning techniques contribute to them getting to those learning goals. That back quadrant, you guys are going to talk about what are the benefits or drawbacks of using active learning in your specific discipline, class, lecture, lab that you teach, or if you're a student that you take. This sort of frontal part, you guys are going to do how can I use active learning techniques within the constraints, so within the physical spaces that I have available, within the time constraints I have available. So a bit the negative, well, how could I fit this in even? And you guys over here, you guys are going to have, how would I motivate my students to actively participate in this, the way I got you guys to participate. So please, feel free, of course, to go off-piste, but I think this would be a really good time to just take a couple minutes, meet the people around you who took time today to come, and here are some things to discuss.
What will be the culmination of
The culmination of that, thank you. At the end, I would like maybe one person from each mini group. You don't have to talk to everyone. You can have like micro conversations, but one of those micro conversations at the end will just sort of summarize a few things that they thought, so that we get that sort of larger scope exchange. So it's like think, pair, share. Great, then to begin discussing, thank you. So I just wanted to ask if people wanted to do the final share. I find this really nice, sort of organic conversations are happening. Again, they're in Czech, so maybe it's about the upcoming who knows what. But if anybody wanted to just sort of give a quick 2-minute summary of maybe some of the things that either you were talking about now with your little assignment, or something else that you just found inspiring that you might want to go forward with and do in your classroom. So it would be great if somebody wanted to volunteer something. I will wait 60 seconds, because I always wait 60 seconds.
should this go in this
No, whoever wants to talk can talk.
Perhaps I can speak for the, what was it, number?
I think I turned it on.
So ours was the topic number 3. I can perhaps add one particular point that I don't know if I can really say that we discussed it. Rather, I informed my colleagues about one particular point that it's our at.
He's wrong, we have discussed it.
So discussed. It's that just at our. It's just that at our department we are right now these days. Actually, a few departments located in Karlovo Náměstí campus. We are currently planning some reconstruction of a few classrooms, and we want to reconstruct them such that they allow some flexibility in how to say put those desks and chairs together in order to form some, let's say, nests or places for 4, 5, 6 students, so that if the room is for, say, 40 or so students, we will have a space structured into 4, 5, 6 or so groups. And the motivation is exactly to support, say, natural forming of groups and then working with these groups. Because as you said, in this particular arrangement, if the hall is full, you can't really access those who are somewhere in the middle. Even if, well, that's it. So that's the point, perhaps for us. Then another point, time constraints. Again, what we discussed was that if you want to insert these moments of communication among peers, you need to sacrifice something of your monologue. So the question is whether or not it could be done differently, that the monologue part, the lecturing part, perhaps could be solved by assigning watching some video or reading some text at home. So these 2 points, simply. Physical space, the information that we think about reconstruction, and time, space, thinking about whether something could be moved out of the group time to the individual time. That's it.
If I may, so if you guys want, I can send a photograph. I was just thinking, I think it's on my cell phone even, so I can maybe upload it before we leave. Imperial College has just redone the lecture theater, and it seats only 10 fewer than the previous lecture theater, and yet it has all of those components for sort of online studying. So you can actually treat it as a regular lecture hall in terms of capacity and just regular lecture, or you can do the active things. I'd be happy to show you the pictures. They just finished the reconstruction. It's a really cool room. And the second thing with the time constraints, if you're thinking of doing something like the peer instruction or the lecture demonstrations, I always say pick one thing, right? Like you don't have to change everything. If you do the peer instruction, it's about 5 or 10 minutes per lecture if you just do one question. That already changes the dynamics. And I don't know if people recognize, but I was always walking around the whole time during those discussions, and a few people did ask questions, and that's sort of also that part of it. So it does take from your monologue, but it doesn't crash your monologue out. It can be maybe a derivation that you normally would have done at the board moves to an online derivation, for instance, and that can buy you 10 minutes pretty easily. So I just wanted to put that out there.
May I share just one more comment on the physical space? Now what attracted my attention, I came across on internet on a person named Robert Talbert, who is a teacher of mathematics in higher education somewhere in the United States. And what struck me recently was that this guy, for his sabbatical, he spent his sabbatical a couple of months with a company producing furniture. So a mathematician, teacher of mathematics, spent a couple of months with a company producing furniture, exactly in this format that he compiled a bunch of paper, or read and put together a bunch of papers on how arrangement of the teaching learning space, how it helps or not teaching, and he collaborated with them, and there were some outcomes. Just if you are curious, look this guy up, Robert Talbert. You will certainly find him easily. He is quite active on his blog and has a bunch of interesting things. That's my point.
Would someone else be willing to? One more person would be great to talk about what they're talking about. The two hosts.
So actually, I have a point. So we should actually reply the last question: how would I motivate my students to actively participate? And I will not talk about this. I have another point. And this is, but it's related. You know, when you ask for the volunteers to come, then the first one was Zdeněk. And when I asked during the discussion in our group, when I asked, okay, so who will be talking on that subject, someone said, okay, you should probably do this. And now this might be also a problem of the active learning approaches. It can easily collapse into a situation that the most active people, so to say, or the people talking most, will take the show. So, what is the way how to actually prevent this?
Great question. So you're absolutely right that that's always a risk. So I have two sort of answers to it. One is the social dynamics anyway. You did discuss it in a group. So even if you're the one who reports it to the 200 people, they discussed it as a group, and they still benefited from that group discussion. That otherwise wouldn't have happened. Of course, there's always the people who are more likely to speak in public than the people who are less likely to speak in public. But they're probably the same people who would have maybe put their hand up anyway to answer a question, and the people who didn't are probably the same people who generally wouldn't ask a question. But given the time as a group, you maybe did ask a question to your colleagues that you wouldn't have asked otherwise. So you don't have to put everyone in the limelight, you just have to give everyone a chance to ask questions to somebody in some platform, big or small. That being said, another trick that I start doing is I go around when I can understand the language of the people discussing, and if I hear them say something good, I'll say like, that was actually spot on. And so I wouldn't pick him because he's in the front. I'll pick someone way in the back. Be like, oh yeah, that was actually really good. Do you mind just saying that for everybody because that was really good? And of course it's hard for them to say no, I get that, but they feel more comfortable that what they're going to say is correct because I've sort of validated it for them. Or I might say something like, oh, I haven't had anyone from the back in 2 weeks. I really need someone from the back. I know it's really awkward, but I know that you guys have been really working hard and I've heard some really good discussions. Could you guys think about doing it? And of course, it is putting them on the spot, but not in a negative way. And if they really go, I really don't feel like it, I go, okay, hey, it was worth a shot. And the next week when I go back, they know what's coming, and one of them usually says, I'm willing to say something. So it's a process over a semester. A lot of times I also would say, what did your group say? So it's not you, it's a bunch of people that could spread the blame in case I say something completely stupid. Or you say, okay, you voted A, but everyone else voted B. Could you give me a reason why you think they voted B? So you again sort of shift it. So they're little nudges, and they're not a silver bullet. It doesn't work that everyone's going to talk, but it does diversify the voices that you hear. So that does change. Mm-hmm.
I wish to have your problems. If there is at least one man or woman taking the show, I would be happy. My problem is nobody. And to solve this problem, a colleague of mine hired an agent. He actually made an agreement with his PhD student to join his master class and to behave like a master student, but very active one. And it really helped.
Yeah.
Start discussing, and then many of them follow.
So I think that's amazing, and you're absolutely right. Generally, if it's a traditional lecture and your question is just, are there questions? It's really hard to come up with a good question when you were just catching up everything, and you don't want to waste your peers' time, you don't want to look stupid, you're worried the professor might actually know who you are and will grade you differently. All those things go through your head, and you're like, I'm going to sit here and wait them out. Mm-hmm. When you have these group discussions and you were saying something, and everyone in your group agreed, that also validates like, oh, okay, at least we all think that. All right, this may be not so stupid or maybe not such a waste of time. And I very often tell my students, particularly more with homework problems, I say, if you guys have all tried it out and all of you still can't get the homework problem, you probably have a really good question. That's not a waste of time question if a lot of you can't answer it. So sort of, and that pre-selection of I've talked about it already and I have a focused question to ask already lowers the barrier to ask that question. Then that sort of, has anyone any questions? And also, let's admit it, we all know the professor doesn't really want questions at that moment in time. It's usually like, oh crap, does anyone have any questions? I have another 10 slides, but anyone have questions? Okay, good, then I'm going to keep going. And we all know that, so we're not going to actually ask a question. So again, it's about the atmosphere in which it's usually done. And that's why I do the wait out of 60 seconds. Because 60 seconds is an awkward silence, and it usually drives somebody to say something. And we think we wait 60 seconds. I have to count too. You wait 3, and you're like, oh, that's already awkward. Okay, no, it's been 60 seconds. No, it hasn't. It's been 3 seconds. You really need to let them think for a moment of a question. And once again, that becomes the norm, and they know that I'm going to wait 60 seconds. It becomes a bit like, all right, let's come up with a question, people, because she's not moving forward. She actually genuinely wants a question, you know.
Maybe one short comment. I love your idea of the discussion seat. Which we would employ. The only problem is that we have permanent positions now, and at the age of 60, it will be difficult to believe that those people are actually master students. So, you know, making this like a general approach might come to technical problems, but it's a lovely idea to have a seat for a discussion.
Well, so.
Yeah, but still, you are credited for it now. I mean, you know.
But we've done that in that when I lecture, I always request a teaching assistant, so a graduate student, to be in the lecture hall with me for exactly, because I use enough peer instruction that there can be as many as 4 or 5 questions in a subject, and with 200 students, and as much as I walk around, I'm still one person. So I would have the graduate student walking around and also maybe probing them with questions and sort of being that model, but it's official. They know this is a graduate student who they can also ask questions to.
They didn't know it. He was undercover.
Interestingly, I have a recent experience that actually the students, the peers, were sort of complaining about that one student were always stealing the show, like always giving the answers and to lead the discussion and so on. So I can imagine that if one does the active teaching regularly, then the students may tend to self-organize within stable groups where they feel comfortable. So my question is it better to leave them as they are, I mean in the comfortable, stable configuration, or induce some reshuffling artificially, just, you know, to pull them outside the comfortable circles and so on?
Yeah, that's a very good question. So you can hold on to the mic for a moment. I don't have a research answer for that. There's a lot of dynamics that play in that, and it would be hard to turn that into a research study where you control the factors and who they're sitting with. That being said, I know Eric Mazur is they have I forget the name of it. There's a computer program where basically from the peer instruction, you also see where the people are sitting as a student, and he'll say, okay, pair with someone who doesn't have your answer, who's somewhat near you, to try to drive the conversation more. I find that is maybe nice, but it's a whole extra level of movement, which sometimes is good, but I tend to think there are people who sit at the front for a reason, and there are people who sit in the back for a reason. Whatever the reason is, doesn't matter. It's just where you feel comfortable. I want everyone to feel comfortable, so I will encourage, I'm saying, if you're feeling a stable group where you're having good discussions, it could be the people at the front are having, because maybe they're more engaged, or having maybe more in-depth conversations than the people in the back, but the people in the back might have just the right conversation for their level, and the people at the front are having just the right conversation for their level, and that's fine. The one thing I'll do is sort of gentle encouragement. Like, if you've always sat in the same seat, try sitting in another seat, because it's always good to hear from someone else. But that's just a gentle nudge. If a couple of students will take me up on it, a couple won't. I always walk to the back, which means even if you're in the back, you're not hidden from me. So that already changes it to like, oh, okay, then this is sort of normal. And in my case, I actually do have a part of the exam where they work together, and they know that going into it. So they write the individual exam, they hand it in, and then they get the same exam as a small group. And it's sort of like, I'm sure you guys had this experience. You take an exam and you go in the hallway afterwards, and you're like, oh, what did you do for number 3? And in that moment, you actually care. And 2 weeks later, when you get it back, you don't care anymore. You don't even remember what you're doing. You just look at your grade, and So I'm trying to harness that, like, what did you get at number 3? And, like, turn it in here, like, here, do number 3 again. Just go for it, like, as a group. And the students generally like this. We're seeing sort of, there's some indication to a longer-term memory on that one, but that's a side fact. But because of that feature, I don't want to say you have to be grouped with people, because that's a high-stakes environment. You should feel comfortable with whoever you choose. So use the semester to find your people that you like discussing with, because later you'll probably use them as your people in your exam. So I have a different reason to sort of say I'm not going to force you to go with people you don't like. This is a great time for questions. So if someone doesn't want to report, but they have a question that's itching, I didn't kind of have questions, I realize that now. So, questions?
I have a question to this group exam afterwards the individual exam. How does it work in practice, the reshuffling of the students to sit in the groups when the lecture hall is once more full of students?
So that's actually not really been a problem. So we usually have the students have to sit every other desk anyway. So the room's always bigger than you need. So that's more than enough space that they can sort of find each other. And then the individual part is over. There's always a couple of students who hand in 5 minutes early. They just sit and wait until the official time is over. And then I say, form your group. Once you have your group, you raise your hand. You don't get the paper until, because I also have to be a little bit careful that the paper doesn't fly out of the room. So once the group is formed, they raise their hand, and the group, as 4 people, got a paper. And they put all their names on it, and they basically have to agree on what's going on. And they situate themselves. It's actually there's a video, if you go to UBC, they actually have a video on the geology site of it going on in action. It's very loud, which I actually like, because some people will be like, what if they hear from the other group? I'm like, they're hearing from their own, I don't care, this is like discussion. Why? This is not about policing, this is about encouraging that they heard from the other group and they got an idea, that's fine. And the students report that they get this immediate feedback. They finally believe me when I say there's more than one way to answer a question. Because when I say it, they're like, sure, but we're gonna learn exactly the way you're showing it. But when they hear from their students in this sort of high stakes environment, they're like, oh, there really is another way of solving it, and that's fine. So you see, they take it sort of serious, very serious, and they reposition themselves physically that they can all see the paper. I've never once seen them actually divide the paper and take the staples and just say, here, everyone do their own. That being said, I do change the questions very slightly so that they're more conducive to conversations. So for instance, I had one on Bernoulli's equation, and in the individual, they had to calculate the velocity at different points and the pressure at different points. And in the group part, it was rank. So the same points, but ranking. Because then you can discuss it. I didn't want everyone recalculating. That's not conversation. If they had just solved it, then they should be able to say, where is it 0, where is it more, where is it less? And that was sort of then the question. So it's the same, because I don't want it to be new questions where then the fastest student answers them and everyone just looks to that person. I want it to be, they've all can contribute equally. And they've all just sort of really gone through it with a serious mindset because it was an exam. And they're really ready for discussion. And the byproduct of that is we see that they're way more active for the midterm when they came back to class the next week, they took the peer instruction a lot more seriously, because I think they realized how beneficial it was in the exam, and it was like, oh, actually, we should probably practice this in our class. So that was kind of a byproduct, but I didn't measure that. That's just anecdotal.
Maybe this is not related to this question this much, but in our country at universities, it feels really exclusive. Like you have to pass all these rules and get the credits and pass the exams, and it feels like the university is pushing you away. And even if you have A's and pass all the exams and have all the credits, it feels like they want you out, and you have to be exceptional to stay in instead of being welcoming and inspiring and motivating to come here, come to join us and learn. And if you have anything to on this topic.
I think you're right. I think that the traditional lecture lends it very much to, I am the sage on stage, you are all my minions, and there's one of you who is good, that's the only person I care about, and everyone else can just go whatever. And that's an awful feeling, and it's very much what's portrayed in that respect. I do see by having the active learning, which generally, okay, I'm someone who likes approachability. I see teaching as more like a coaching, and I really try to imply that to the students, that if you all fail, I fail, right? There's something wrong with my exam if everyone failed it after going through my whole course, then there's some mismatch. So I want people to pass, but I'm a coach. I'm not playing the game, right? I'm having you run the laps, and you're gonna play the game at the end, but I still want my team to win as the coach. And I need to see you run those laps so I can help you get better. That's why you have to do the homework and I don't have to do the homework, sort of thing. But I set the tasks just right so you'll get better. That's the message I always want to have. I'm a trainer, I'm a coach, I'm a music instructor. I use all different sort of ones that all have that same theme. The university maybe doesn't have that, but if every individual professor did really want people to learn, that'll be felt. And the active methods where like I said, you just break that physical barrier where I'm just walking around already changes a little bit the dynamic of, oh, maybe I can actually ask this person something. By me seeing the feedback and talking about the feedback I just got from the students changes the dynamics. By me saying, hey, I want some answers. So sometimes when I do peer instruction, I have a question, and I think it's a good question, but I don't have any good multiple choice answers. So I'll say to my students, look, I think this is a good question. Everyone, please write down your answer just on a piece of paper and drop it in the hat on the way out, because I'm going to use your answers for the multiple choice next year. And so they're part of the process. And all that makes them think like, oh, like she actually cares about what I say. And then you feel more valued. And that's what I meant by the sense of belonging. That's a really important thing. And if you are non-white female, particularly non-white female in science, you generally don't have that sense of belonging. And if you get something wrong, you think it's because I don't belong and not because maybe I didn't study enough. And these kind of methods help to illustrate that a lot of people are struggling, a lot of people got it wrong, it's not just you. And that also encourages that sense of belonging with the discussion. So I think all of that can indeed shift that mentality, but it is what the classroom norm is that the professor sets. And that can be different from what the university sets, because that's the freedom of the teaching at university. So if all the professors here were to sort of kind of have that approach of very much openness and very much encouraging it, I think that will sort of start to grow. And that's when the students start to recognize and start saying, hey, I want this. And then hopefully university admin people will wake up and say like, oh, we should actually promote this. This is a good thing. But that's sort of a couple years down the line. Hope that sort of answered your question a bit. Okay. Oh, another question?
I've heard an interesting question here. It's not from me, but again, with the group exam, how do you grade it? Do you grade it?
Yes. No, these are absolutely valid. I have like slides for this, but I didn't prepare them for today. We do grade it. If you Google this as a paper, you'll come up with like 2 or 3 papers that I was one of the co-authors of, but the short and dirty is it's less grading work than you would think. So we start by grading the group exam because those tend to be more correct, and those become I'm only thinking of the German word, the Musterlösung. Well, the English is slipping. The master, the key, right? Right? So like usually you create that yourself and then you look at what the students did, and if you're giving partial credit, you're kind of like trying to figure out what the student did. By starting with the group ones, which generally are correct, you kind of have student generated master solutions. And now you know what a good student solution looks like, and then you grade the individual, and you kind of go pretty quick at that point because you've gotten used to that one. So we found for grading time, it was maybe 10% to 15% longer for grading time, which is not massive. And we had 4 sections, each with about 200 students, so it's 800 students. So I mean, grading anyway took us, with a team of TAs, half a day and pizza. So when we added the group exam, it was half a day and pizza and an extra hour. It wasn't massively different. And we did grade it 85% for the individual, 15% for the group. So you had to pass as an individual on your own merit, because that's important. I have to be able to know that you can do something on your own. The 15% was sort of just shifting your grade a little bit. And we did put in the caveat, if your group grade were to bring your grade down from your individual, you could keep your individual. So we didn't want to punish anyone with the group. But I said, take that as a personal learning experience that you couldn't convince, you were more right and you couldn't convince these people you were right. Take that home, because later in life you will need that skill to be able to convince those people. But I'm not going to penalize you right now with your grade. That seems sort of silly. So by having those things in line, we had, I think we did a study with, 200 students' comments, and of the 200 students, they each commented 3 or 4 sentences. So that's, again, 1,000 sentences, and I think there were 15 sentences that were marginally negative. I mean, the experience was generally overwhelmingly positive in terms of learning, feedback, just enjoyment. The one negative was, I found out I didn't do so well on the individual, but then it was like, well, you just found out sooner rather than later. It doesn't change what you did on the individual. But yeah, okay, fair enough. It was kind of a crappy feeling, I get it. So that was sort of how we did it. And I know colleagues who've done 10% to 90%. I wouldn't go much below 70% because I really think the individual still has to pull their own weight personally. But I don't have data backing up like what number combination is best. This is a little bit out of sort of gut feeling.
Right now, time flies. It's 6 p.m.
Oh my God.
So I guess it's really high time to call it a day. And that's the high time to thank Cynthia for coming, for sharing, and for provoking us, stimulating discussion here. I guess you liked it. And this will only be seen in 1 month's time if anyone is appearing here on another second seminar on teaching and learning in higher education in STEM fields in Davice campus. So thank you for coming, and see you in 1 month's time, I hope.
Thank you.